Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Muhammad Ashraf bin Arifin from 4SKTK School of Chemical Engineering, University Technology Malaysia. I'm going to talk about our project here, which is the miniature bioreactor as research tool for biotechnology process development. This project is supervised by Dr. Nazrul in collaboration with Dr. Sani and Dr. Johari, with a few contributions from my friend Muhammad Zainuddin and Muhammad Hafiz. Okay, enough with the introduction. I will talk about the outline of this presentation. I will talk from the summary of the project all the way to the challenges and improvement. Okay, for the summary of the project, this presentation is all about by talking about the technologies currently available in the market, and also the redeeming features of our product, and also the significance of our product to the biotechnology sector. Okay, we can take a look here. There is two types of bioreactor we can compare, which is the first one, the bench scale bioreactor, which incorporates 1 liter to 5 liter working volume. It is also fully equipped with pH sensor, temperature sensor, DO level sensor, pumps and actuators. It is also fully automated with built-in processors, but it also has limitation where it is low throughput, it is also laborious, and the sampling is done manually. We can compare this to shake flask platform, which is using 0.1 liter to 1 liter working volume. It is also high throughput and also easy to set up, but it also has limitation where there is no sensors or actuators because it is difficult to install under shaking condition, and of course the sampling is done manually. Okay, we talk about the problems and issue that are faced by the researchers. The first issue is that the reactor vessel is heavy to carry, so it is difficult to sterilize and to clean. The second problem is that it is labor intensive, where it requires sampling for every 1 to 2 hours. I mean, nobody likes sampling for 1 to 2 hours for an experiment. The third problem is that it is costly, where it need 1 liter of medium for every experiment. Okay, we talk about what's currently available in the market. There are two types of bioreactor. The first one is shake flask platform, and the second one is mini bioreactor, which is a scaled down bench scale bioreactor. It both has low working volume, but there are also flaws in them where the sampling is done manually. From there, I want to introduce you to our solution to the problems that faced by the researcher. This is our solution. Here with me, I brought you our solution, which is the mini bioreactor prototype. The features for this prototype is that it is equipped with temperature sensor, Hall effect sensor, and also turbidity sensor, and also actuators, so that the temperature and agitation speed can be controlled. It is equipped with built-in miniature air pump, so that air can be continuously supplied. It also incorporates low working volume, around less than 100 milliliter, and the most significant of this prototype is there will be no sampling needed. Okay, from here I want to talk about the methodology, how to make this product. The first step is by fabricating the reactor vessel by using PDMA or PMMA plastic, PDMS or PMMA plastic. It will give the disposable element to the reactor vessel. And the second step, by fabricating the controller box by integrating the Arduino microcontroller platform. The second step is integrating this vessel with sensors, which is like the temperature sensor, Hall effect sensor, the turbidity sensor, and also actuators like air pump, and also the steering element, and also the heating element. And then we need to proceed with automation setup for the Arduino microcontroller platform on the PC. After all of that done, we can run our experiment by using any strain that we want. Alright, enough with this. I want to talk about the performance overview. Okay, the picture in front on the screen is a sequence of picture showing the mixing process. This picture, in just 1 second, we can see that the dye is instantaneously mixed homogeneously into the mixture. So from here we can prove that this prototype mixing performance is rapid, homogeneous mixing and well distributed, so we can hope that it can maximize the yield. Okay, the figure here is the comparison between minibioreactor and Shake Plus platform performance in fermentation. The blue dots represent the minibioreactor and the yellow dots represent the Shake Plus. We can see here the interval for every sampling for the minibioreactor is around 10 seconds. On the other hand, Shake Plus platform sampling around 1 hour. So incorporating the shorter time interval and the mixing performance, we can see the performance the yield for minibioreactor is higher than the Shake Plus. Alright, we go to the impact for this prototype. The first impact is toward the researcher, where the contamination risk can be reduced, the labor works can be reduced, and also there will be no sampling needed, so experiment is no longer a hassle or labor intensive. The second impact is toward biotechnology sector, where it is high throughput, so we can reduce running costs and waste production. So it also pioneer the automation development in this biotechnology sector, and also we can depends on the accurate and reliable data from the experiment we using this prototype. The third impact is toward the society, where it is possible to introduce this minibioreactor prototype to the secondary school syllabus. From there we can serve early exposure towards biotechnology amongst the student, and from there we can increase their interest in biotechnology, and hopefully we can produce young talents in the future. Alright, in producing this prototype, there is several challenges that worth noted. The first challenge is that the vessel fabrication is a hassle, and how to tackle this is by making stocks or by using multiple use vessel. The second challenge is connecting the wires to the compact board is very tedious. So how we tackle this problem is by increasing our skill in electrical wiring by attending courses or workshop. And the last one is every sensor needs a specific coding. So to tackle this problem is by finding a ready-made coding in the internet. It will help us a lot. This prototype can be improved by using artificial intelligence, or by integrating long distance monitoring, or Internet of Things, IoT. That's all from me. I want to take this opportunity to acknowledge to acknowledge Dr. Nazrul, and also the funding for this project granted by UTM. And also, if you have any question, feel free to ask. Thank you very much.